Hello everyone, in this video I will explain how to construct the intermediate data structures which are used in designing the solution for minimum cost spanning tree using the Prim's algorithm. This graph is of 6 vertices. So first step is to just draw a blank 6 by 6 matrix and put all the diagonal elements as 99. Okay. Now I am showing you the quick trick through which you will be able to construct this matrix for the given graph. First important point is don't start from vertex 1, start from vertex 6 because it has maximum entries here. So 6 is not connected to 1, so write here 99. 6 is connected to 2, 25. 6 connected to 3, 15. 6 connected to 4, 20. 6 connected to 5, 55. In this way, we are done with vertex 6. Then we go to vertex 5. 5 connected with, don't take 6 now. So 5 connected with 4. 5 connected with 1, that is 45. 5 connected with 2, that is 40. 5 connected with 3, that is 35. 5 connected with 4, 99. Not connected, hence 99. Then take vertex 4. Again 4 connected with 1, 30. Not connected with 2 and also not connected with 3. Then take 3. 3 is not connected to 1, so 99. But 3 is connected to 2, so 50. Then take 2. 2 is connected to 1. In this way, quickly you will be able to construct the convert this graph into matrix, and this matrix is called as lower triangular matrix. Now we go ahead and try to find out the remaining concepts. We already have this matrix. This is the solution for the spanning tree. Solution is also represented in the form of three tuple form, TTF, because it has three columns. This is column 1, column 2, and column 3. Now, first step is to find out the smallest entry in this lower triangular matrix. This smallest entry is 10. So we will write, first we'll write word. So this entry is at column 1 and row 2. So we can write it as 1 comma 2 equal to 10. And we'll make, this is the structure of near array. Okay. This near array will have 6 positions because there are 6 vertices. And since we have selected vertex 1 and vertex 2, because this 1 comma 2 in the graph is 10, we will keep these two entries blank and we'll put remaining entries for our calculation. Now, how to fill this remaining entries? What are these remaining entries? These remaining entries are vertices 3, 4, 5, 6. And we want to find out whether vertex 3 is close to vertex 1 or whether vertex 3 is close to vertex 2. Similarly for 4, similarly for 5, and similarly for 6. So to find out whether vertex 3 is close to vertex 1 or 2, just check the row of vertex 3. So it is 99 and 50. 99 is greater than 50, so we will write 2 here. Similarly, check for vertex 4. Just check the row of vertex 4. So if it is, and you don't have to go beyond column 1 and 2 because you have only picked vertex 1 and 2. So 30 and 99. So for 30 and 99, the smallest value is 30, which is in column 1. For vertex 5, the smallest value is 40, which is in column 2. And for vertex 6, the smallest value is 25, again in column 2. What is to be picked after all this? That is decided using the values which you have selected. So first value selected was 50, second value was 30, third value was 40, and fourth value was 25. So out of these four values, the so this was already picked. The minimum value is 25. So since minimum value is 25 and it is at row 6 and column 2, you can write this as 2, 6, and 25. Okay. And now we need to check. So once you are done with 2625, make this particular location blank, and we need to check for only 345. So this is the important step of the algorithm. Originally vertex 3 was close to vertex 2. Now check whether vertex 3 is close to 2 or close to 6. And if it is close to 6, then use 6. How to do that? Simple. Check vertex 3. Okay. So vertex 3 is close to initial cost of vertex 3 and 2 is 50. Okay. Now we want to check whether vertex 3 is close to vertex 6. This can be checked by finding 6 3, that is 15. And since 15 is less than 50, we will write here 6. Similarly, go to 4, check whether it is close to 1 or close to 6. So 4 is currently close to 1, that is 30. But if 4 is better reach than 30, then check for 6. And 6 to 4 is 20. So we can write again here 6 because 20 is less than 30. And again for 5. So check whether 5 is close to vertex 1 or whether it is close to vertex 6. So 5, 6 is 55. And since we are talking about vertex 1 and 5, which is what? 45. So since 55 is greater, we will continue with vertex 2. Now what is to be selected? So for that, again check 3 6. That is, what is 3 6 in the matrix? 15. What is 4 6 in the matrix? That is what? 20. Okay. And finally, what is uh, 5 2 in the matrix? Okay. So since it's a undirected graph, you can take 2 5 or 5 2. Both ways are same. So 5 2 is 20. Okay. 5 2 is 40, not 20. 5 2 is 40. And out of all this, 15 is best. Okay. So then we will take this combination and we will write 3 6 and value is what? 15. And we will make this entry and we'll make this entry blank. So which new vertex came is 6. Now check whether vertex 4 is better for 6 or better for 3. Again, vertex 4 is better for 6 or better for 3. So we will have 20 here. Okay, fine. And if you take what? 3, that is 99. So we will continue with 6. Okay. Then check 5. And since 5 will be checked with 2 and 3. Why 3? Because 3 has came just in the previous step. So 2 and 5, that is 35. 2 and 5 is 40. And 3 and 5 is 35. So which is better is 35. So we'll write 3 here. Now out of these two entries, which is better, that we need to find out. So 4 6 is 20 and 5 3 is 35. So we will have to take next vertex as 4 and we are left with vertex 3. So we'll write here 4 and again 6 and value is what? 4 6 value is 20. Okay. And finally, we can write 5 3 value is what? 35. So in this way, we will get the spanning tree written in the 3 tuple form, which is a matrix of size 5 rows and 3 columns. Because you have 6 vertices, you will have 5 edges in the spanning tree. If you have 6 edges, then there is a possibility of cycle. So this is the clear idea about Prim's algorithm. Hope you have understood this concept. Thank you.